All right, Kuta Quadratics practice. Let's dive in. We have b squared minus 4b plus 4. Now we could use the quadratic formula, keeping in mind that the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. But if you can factor, you should factor. Note that we're trying to find the two numbers that multiply to get positive 4 and add to get negative 4. Well, that's the same number. It's negative 2. This should be jogging back some memory from middle school. Then you set each of these factors. This is a factor, and this is a factor. You set them equal to 0. And in this case, you get b equals 2. And over here, you get b minus 2 equal to 0. Obviously, b is equal to 2. Equals it twice, so we just get one of them. Let's do the next one. Now, once again, you want to try to do this by factoring or the quadratic formula. In this case, since we have a number bigger than 1, I'm going to choose to do the quadratic formula. I take these numbers and I simply plug them into the quadratic formula. Negative b, I'm going to simplify as I go. Plus or minus, this is x equal to, by the way, the square root of b squared is 9, minus 4 times a times c. I'm just going to write 4 times a, and a is 2 and c is negative 5. That means this is going to become positive. 4 times 2 times 5 is 4 times 10, which is 40, all over 2a. 2 times 2 is 4. This becomes x equals 3 plus or minus the square root of 9 plus 40, which is 49, all divided by 4. This 49 becomes 7. We have 3 plus or minus this. X equal to that. Change the colors. And then this gets split apart into the plus and then the negative. So we have x equal to 3 plus 7 divided by 4, and we have x equal to 3 minus 7 divided by 4. We just got to solve each of those. 3 plus 7 is 10. 10 divided by 4 is 5 divided by 2. And then we have 3 minus 7, which is negative 4. Negative 4 divided by 4 is negative 1. And that's it for that one. Let's go to the next one. Now in this case, I'm going to try to do this by factoring, because I think you need to see this, and I don't know if all of you have seen this from middle school. Let's say we wanted to factor this. To factor it, we're going to have to take this number and multiply it by the last number, checking first that you need to, if you can factor out anything from all three. All right, so I'm going to take this 2 and this negative 20 and multiply them. Then I'm going to take this 3 and write it beneath it. This is called the little X game. It helps you to isolate your guess and check. We're trying to find two numbers that multiply to get negative 4 and add to get 3. Think about that for a second. Let's try to find two numbers that multiply to get negative 40 and add to get 3. If you can't find these numbers, then this is not factorable. Let's see. 20 times 2, 20 times negative 2, that doesn't work out. It needs to be a little closer. 4 times 10, those negative 4 times positive 10 is negative 6. So what about 5 and 8? 5 and 8 work out. Now they add to be a positive, so the bigger one needs to be positive, and this is negative. Now this tells us that the 3x can be split apart as positive 8 and negative 5. So I'm going to use that in my writing of the next line. Notice I still have that 2x squared, and then I still have the 3x, but the 3x becomes negative 5x and positive 8x. If I were to combine this one and this one, I would get 3x. And this is going to be subtracted by 20. Notice this equation, which I have circled in black, is equal to this one. Awesome. Let's do the next statement. Next step. We're going to identify something that both of these share. I'm going to underline it twice. The only thing they share is an x. That means I'm left with 2x minus 5. I'm going to factor these over here. I'm going to underline it with red. Factor these two. Now, the only thing they share is a 4. So I'm going to factor out a 4. When you do that, you've got 2x minus 5. If you notice, this here is the same thing as this here. Now, this is crazy because this over here, if you can do this, this happens and this happens. All right, the next part is a little bit tricky, and it's called factoring by grouping. Where you see the same thing, you pull only one of them out. This becomes 2x minus 5. And then whatever's left over, which in this case is x and 4, we pull both of those out and turn them into a binomial with that operation. So x plus 4, that is factored. Now I just need to work out each of the factors. Now if one factor equals 0, then the whole thing is 0. So I just set each of these factors equal to 0 and solve. And that becomes x equals negative 4, and 2x is equal to 5, which means that x is equal to 5 halves. That's it for that one. Well, let's do another. This case, remember that if we have a square, a singular, and a constant, we're going to have to solve for 0 before moving on. So let's go ahead and do that before we continue. So we have 2m squared minus 7m, negative 13 plus positive 10 is negative 3. In this case, I'm going to do the quadratic formula. We can go back and forth between those two forms. A equals 2, b equals negative 7, and c equals negative 3. I just simply plug it in and chug it out. Negative b plus or minus the square root of b squared minus 4 times a times c. 4 times 2 is 8. 8 times negative 3 is negative 24, but that becomes positive 24. I'm going to check my work. B squared minus 4 times a times c. 4 times 2 times negative 3 is negative 24, but we have we have a negative, so it makes it positive. All over 2a. 2 times 2 is 4. This is x equal to. Awesome. 49 plus 24 is 60 plus 13, which is 73. Now this is not working out to be a pretty number, which means that this is not factorable. But I'm going to grab a calculator and confirm that my arithmetic is correct. Otherwise, you guys are going to make me do a push-ups for all my mistakes. So we have b squared, so negative 7 squared, plus or minus 4 times, if I can get this right, 4 times a times c. Just checking out my work. Looks like I did something wrong with my arithmetic. I was feeling like I did. So we have b squared minus 4 times a times c. Looks like this should have been 31. Sorry about that. This is a one-shot video, so I'm not going back and fixing that, but you got the basic idea of how we're doing this. 4 times a times, maybe it'd be good if I square my 7. Sounds like I probably did have it right. And I did have it right. I apologize. It is correct. Let's continue. All right, so we have 7 plus or minus the square root of 73 over 4. Now 73 is considered a factor. There is no perfect square factor of 73. So this is technically the form of the answer that we would prefer. Now notice, since square root of 73 is not a pretty number, this original equation is not factorable. And this hints at a key idea with quadratics. The quadratic formula always works. That's it for the video. I just wanted to give you a basic stuff.